I should have totally known. Thank you, though. All right, so here is the notes. All right, so what do you see here? What do you imagine? Anybody? Thank you, Amar. I appreciate that. I'll update your the grades. I see your note. What do you imagine? Anybody? All right. Well, I imagine my cool Tesla, right? All right. There we go. Imagine that. Okay. And what do you imagine here? What do you imagine there? What is your mind seeing? Anybody?
What do you mean?
So when I write this word or this collection of letters, it's a symbol, right? This is a symbol for this drawing or a car, and this is actually another drawing. So what does this draw? Like if you were to graph it, what does it draw?
Is it like the acceleration?
It could be the accelerate. Well, actually, that's good physics. Good physics word. So what do you imagine if we were to graph it? We graphed a few of them last week, right? And what does it draw? What shape is it? If you look at your notes from number 5 or number 4, what shape are these things? And you can just unmute your voice microphone or just type in the chat. I can actually see both at the same time right now. All right. I'm going to just, in the interest of transparency, do you imagine this? Do you imagine this? Do you imagine this? Which of the three graphs do you imagine when I say f of x equals x times x? The last one. Thank you, Claudia. Yes, this is a parabola, right? So I want you to start looking at functions with x times x, you visualizing a parabola, all right? So this is a parabola. Now, it might be upside down, it might be thin, it might be wide, it might be stretched, but it's still a parabola, okay? So when I was a kid, I would see this and I would really didn't, it looked like Chinese to me. I didn't even understand what it was, but I want you to start imagining it's going to be some parabola somewhere in the coordinate plane, okay? Um, so today we're going to do a new function, and I'm going to call it I don't know what letters after F. G. G. G of x. And remember, G is the name of a function, right? Just the name. And then the inside of here is the input letter. And it's actually the input variable, but all right, today's intro is this. And that's what's going to be today's lesson is an X with this little bars around it, okay? And make sure they're tall. They're taller than the X because otherwise they look like ones. All right. So before we get into this, now we can actually use Desmos to look at it. But before we do that, we're going to do a number line and 0 here. And on the right side, I'm going to use blue on the positive side. And on the negative side, I'm going to use red. And then let's find this out. Ready? I'm going to say, how far, put black, how far is 5 from 0? Okay. So how far is 5 from 0? Everybody?
5.
5. Now, I'm going to say that exact same um, sentence in Mathanese. So this is exactly saying this sentence right there. Okay. Simple, right? All right. Here is another sentence. Let me scroll this up a little bit. Here's another sentence. How far should I write the English or should I write the Mathanese?
Both.
Both. Let's do it. Thank you. How far is -5 from 0? And how far is -5 from 0?
5.
Also 5, right? And I'm going to write that in Mathanese. So I always talk about when I was your age. But when I was your age, I thought the absolute value meant make everything positive. And it does. The negative turns positive. But that's not really what it means. It really means how far is that number from 0? I always fail to understand that. Okay. I'm going to blame my teacher because that's what kids do, right? Blame their teacher. I'll blame my teacher because I never understood that. I always said, oh, whatever is inside of here, it turns positive. But that's like superficial thinking. That's not really understanding what the question is. The question is, how far is it from 0? Okay. And distance is positive, right? You distance from two different objects is a positive number. Okay. All right. So far, so good. All right. Let's do 3 more. How far? Whoops. Hold up. How far is -7 from 0?
7.
7. Okay. Easy, right? Easy. Did I spell easy? I don't even know. Okay. All right. Let's bring it up a notch. This is a different question, and I'm going to write it in English. What number is 7 from 0? Or number or numbers, right? So what number or numbers are 7 from 0? Anybody?
7 and -7?
Yes, 7 or -7 are both 7 from 0. See how the question changed? When the x is inside the absolute value, it means what number is 7 from 0? And both of them are 7 from 0. So how many answers are there? Okay. All right, let's do 2 more of these and then we're going to start graphing this, okay? All right, now we're going to, that's level 2. This one says, what number is 7 from 0, but you added 2 before you got to 0? Hold on, let me think of how here's how I'm going to say it. X plus 2. No. How can I write this? How can I ask this in English?
Would it be 5?
Yeah, 5 is one of them. That is correct. 5 is one. What's the other? So you know that inside of here, it equals 7, or it also equals what? Does that make sense? So what's inside the absolute value, it is equals 7. So I'm going to write that. X plus 2 is 7, or X plus 2 is negative 7. So what plus 2 is 7? Amar, you said is what? 5. And what's the other number? What plus 2 is negative 7?
Negative 5.
Negative 5. Okay, that's good. That's a good guess. Negative 5 plus 2 is actually negative 3. That's a pretty good guess. By the way, how would you get rid of this negative plus 2 here?
Would it be negative 9?
There you go. Now you're thinking. Okay, make sense? So it's not just the opposite number. It's this number right here. So negative 9 plus 2 is negative 7, and negative 7 is 7 away from 0. So what are the answers here? 5 or what? Negative 9. Okay. So here is the way I used to remember how to do this. Whenever I had like stuff inside, I would make two equations. One normal, and the other one, I would change the sign of the over here to negative. All right, who wants to try another one? Just like this, not a harder level, just like this one.
Me.
Okay, all right, let's try another one. And I'll continue with that 7, just so that I don't switch it up on you guys. Okay, 3x plus 2. Let me change that 3 into a 2. 2x plus 2, absolute value, is 7. So remember, my technique was to write two equations. One, normal. And the other, almost normal, except I would change this to negative. There we go. So go ahead and solve both of them and tell me when you're done. Don't tell me the answer, but tell me when you're done. Okay, I'm giving you guys time to do it. Go ahead and do it on your own. I'm going to do it too, but try not to look so that you can see if you're. Or let me know when you guys are done, or when you've checked my work to see if we're on the same page. Okay, Nathan's done. Good. So this was my technique, right? I would draw one the same, just get rid of the absolute value, and then on the other one, I would change this sign. I would change it to opposite. Opposite. I'm going to say opposite because what if it was negative? Then you would turn it positive. Okay. Okay. Thank you. All right. So that is my intro to absolute value. So when I say absolute value, you're thinking how far something is from zero. Okay. So now what we're going to do is we're going to graph a function like this. So I'm going to start a new page, and I would like you to do a new page too. 'Cause we did a lot of work here.
Can you do that one again?
Yeah.
I'm still kind of confused on it.
And yeah, of course. So this question right here says something is something, and I'm going to call this something. Okay. Actually, I'm going to call it Billy. Billy is 7 from 0, right? 7 spaces from 0. Do you agree with that? So Billy is 7 spaces from 0. So Billy could be here, right? Or he could be where? Does that make sense, everybody?
Yes.
So he could be in 2 different spots, right? And he's 7 spaces from 0. So in order to solve each one, we can solve if Billy, see here's this is Billy. Billy is at 7, right? He is at 7. So all I got to do is get x by itself. So I subtracted 2, right? And that subtracted 2. And then I got this cancels out. And 2x equals 5. 2 times something equals 5. Well, you know the 2.5. Well, you could divide by 2, right? And then you're like, hey, half of 5 is 2.5. So x is 2.5, which means if you plugged in 2.5 here, all of Billy would become 7, right? And he would be at 7. But Billy could also be over here, right? So here's Billy, right? So Billy could be at -7. So we do the same thing, right? Subtract 2, subtract 2. This cancels out. 2x equals -9. So divide by 2, divide by 2. So x equals 4.5. So either x is 2.5 or x equals -2.5. There's two possible answers. Thank you for asking. Was this helpful a little bit?
Yes.
Okay. All right. So the idea is don't just think everything turns positive. That was my mistake. You know, nothing turned positive. We're just finding something is 7 from 0. This tells you how far they are from 0, right? This tells you how far they are from 0. This tells you where they might be. They might be at 7 or they might be at -7. That's the only 2 spots that he could be where he could be at 7. Now, if we were 3-dimensional, technically he could be up here, right? This could also be 7, right? And he could be over here, and he could be 7 on the y-axis. And then you could do the z-axis, and then it gets a little crazy. But right now we're just intro. All right, so let's go to screen 2. And remember, in your notes, you got to have all the stuff, okay? So some people are just going to come in here and then copy, some stuff I have, and I can see everything because a lot of you do take really good notes, and I use yours as the basis for what good notes should look like. All right, here's the real lesson. Here we go. F of x equals absolute value of x. Okay, so we need to make a table, just like we did with quadratics. X, and then the y, right? In the work. All right. And in the beginning, I like to go from -5. Whoops. I'm sorry. I'm going to start with positive ones. This is what they look like. They're going down. All right. And the work is, how far is 5 from 5? 5. How far is, now, like I said, I don't really have to do this little piece, but I want you to see it. How far is 3 from 3? How far is 2 from, I'm sorry, not 3 from 3, 3 from 0, right? 1 from 0. How far is 0 from 0? How far is -1? How far is -2? How far is negative 3? How far is negative 4? Now I'm going to switch colors because I wanted to do the y's in red. So this is going to be 4. How far is 3 from 0? 3. How far is 2? How far is negative 1 from 0? 1. How far is negative 2 from 0? 2. How far is negative 3 from 0? 3. How far is negative 4 from 0? 4. Okay, so now we can graph this. Now, the reason I started with quadratics, just the intro to quadratics, we're going to come back to them later, but I wanted to start with that so you can see it was a U shape, right? Remember this? X times X drew this, or not drew, but forms this graph. What do you think this is going to draw? Okay, all right, let's do the first one. I'm going to start at the vertex, the lowest point, right here, right there. All right, and then 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. All right, let's graph this. All right, Leah, what color should we make this graph? Since I already used red for the number line and something will stand out. What's that?
Orange.
Orange, okay. All right. So I got 1 point here, 0, 0. I got 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Negative 1, 1. See that one match this one? Negative 2, 2, negative 3, 3, negative 4, 4, negative 5, 5. Does this shape look familiar, similar to the quadratic? Or is it more like a V? Right? So this, if you connect the dots, because you could have put decimals too, like 1.5. There you go. So this is the shape of the absolute value of x. Okay. You could put a y or f of x, whatever. Okay. Actually, I'd rather put f of x. Let's do that. It's the same thing. So this is the shape. The shape is a perfect V shape, really sharp. Okay. And what is the shape of this one right here? Is this going to be a V or is this going to be a parabola? Now, I don't really call this a U shape too much because it gets wider and wider, right? But it is a U-ish. It's a U shape in the bottom. Okay, that's a difference. Okay, so the difference is absolute value is a sharp, and then the quadratics are a smooth. So if you threw a baseball up in the air, would it do this or would it do this? Which one would it be? This is an upside down, right? A negative. Okay. All right. So let's look at one example. Then I'll let you guys do the Khan Academy. We'll do it together, though. Okay. Let me look at one of the problems. Go ahead and ask me questions while I'm getting it ready. Okay. And I'm gonna just do one, and I'm gonna do it on paper. Okay. All right, y equals absolute Shift left. Okay, so there's some shifting going on. All right, so what we're going to do is we're going to do another one right here. Hopefully you have some space. I'm gonna call this one FGH. H of x is the absolute value of x plus 3. And what do you think we're going to add 3? Are we going to add 3 to the x's or to the y's? What would be a good guess? I mean, just a guess, right? Anybody have an idea? Are we going to add 3 to the inputs or the outputs? Here's the work, okay? Let me zoom in so you guys can see that. All right, and let's start with 5, 4, 3, 2, 1, 0, -1, -2, -3, -4, -5. Okay. All right, so inside here, I'm going to go ahead and just write this thing out all, even though I could totally do this in my head. But I want you to see that you're not always going to be able to do it. I'm leaving a space so I can put the number in here. All right, I'm going to put 5, 4, 3, 2, 1, 0. -1 plus 3, -2 plus 3. And if I'm going too fast, please let me know, okay? I can slow down, no problem. All right, 5 plus 3, 8. 4 plus 3, 7. 3 plus 3, 6. Oh, looks like it's going down by 1. I can almost stop thinking, right? Watch, I'm going to stop thinking. You tell me where I went wrong. Tell me where I went wrong.
It's -2.
It's -2. Let's see. How far is -1 from 0? I'm right here. I'm right here. How far is -1 from 0?
1.
1. What's 1 plus 3?
4.
4. This is actually what? 4. The same as this 4, right?
So is 3 your lowest value?
Yes, that would be your vertex. Good catch. Remember, in my quadratics, my favorite starting point is the vertex. Now, the reason I like the vertex because I can just do half of the work. Okay. All right. This one right here. Is this 3 minus 2 or is it 3 plus 2? So the question is, how far is -2 from 0?
2.
2. So this is actually 2 plus 3 is what?
5.
5. Then you can start using the pattern, right? So be careful with the absolute value of negatives because they are a positive distance from 0. So where is your lowest point? Right here. And then these will be mirrors of each other. Look at that. Make sense? Now, if you were to graph this one, which we will, would it be like this orange one? Would it be raised, lowered, shifted to the right, or shifted to the left? Would it be up 3, down 3, to the right 3, or to the left 3? What do you think? Let's start at the vertex. What was our, yeah, thank you. Thank you. Isaiah said up. Our old vertex was 0, 0. What's our new vertex? So it used to be here. Now it went up what? 3. So I'm just going to be real, what's the word? I don't want to say lazy, but you get the idea, right? So everything went up 3. All y's went up 3. So remember earlier I said, do you think you're adding 3 to the x's or 3 to the y's? Look at this 5. It used to be 5. Now it's 8. Used to be 4. Now it's 3. It's kind of weird, huh? Because it says x plus 3. It doesn't say y plus 3. But the thing is, absolute value of x will become y. That it will be the new output. Okay? All right, so this went up 3. Now, without drawing it, we don't have to draw it. I'm going to use a new equation, function, and that's a L. The absolute value of x minus 3. What do you all think this v is going to look like? Is it going to be up, down, right, or left? What do you think the shape of it? I mean, not the shape, the location of it. It would have been a 0, 0, but this dang negative 3, did it go up, down? Okay, a lot of people here on my chat, or a couple of you guys, are saying down 3. Yes, so my old vertex, I bring it down 3. 1, 2, 3, and I have the same V shape. Nothing else changed, okay? So this number out here tells you whether it's going to go up or it's going to go down, okay? Now we're almost done with today's lesson in terms of this. So we did the up, we did the down. Can somebody for 1 million points come up with one that'll make it go to the right? To the right 3.
Positive 3?
Positive 3. Well, positive 3 made it go up 3, right? See that? And what you could do, and I'll give you guys time. Let's all go to Desmos. Wait, don't go to Desmos until I show you. Okay, so go to Desmos, but don't go to Desmos yet. Okay, and I'm going to give you guys instructions, and then you guys will play with this and see if you can figure it out. So here's my function: f of x equals absolute value. Where's the absolute value? Is it this one? Hang on, I got to move this. This little tool. Here it is. So absolute value, functions. Oh, here it is. X. Okay, so here's our V. Very nice. And then we knew that if we put plus 3, it went up. And then we put minus 3, it went down. So I want you to do something and tell me how to make
Divide.
it go to the right. I want to make it go to the right 3. All right, so you guys go ahead and go to Desmos and then put this function. And then you can call it G. And then make it be a V shape and have it be over here on the right side, over here. And I'll give you a hint. You got to put a 3 somewhere. And we know that if it's outside the parenthesis, outside of the absolute value, it makes it go up and down. A way for everybody to kind of test it out. And it's going to be somewhere. And remember, the absolute value is right here underneath the parentheses. Okay. And you could also type it in the chat if you came up with it. I want it to be on the right. I want it to be drawn over here on the right side. I want this blue to be over here to move to the right. Okay. What do you multiply? Kennedy thinks you can multiply. Kenny, where did you put the 3? In front of the x or outside of it? Outside. Okay, let's see. If I put it outside, it looked like it got skinnier, but it's still it looks like it's skinnier, but it's stretched by 3. But it didn't move it to the right. I want this to be moved. I want the vertex to be. I want the vertex to be at 3 comma 0. At 3 comma 0. I want the vertex to be right here. No, the other way. Okay. So we put the 3 here. I put on the inside. It didn't. No. So I want the vertex to be right here where my green dot is. Aha. All right, Shiv, can you tell us what it is if you don't mind unmuting your mic? All right. Okay, no worries. All right, Shiv figured it out. I don't know if his mic's not working or not, but he put -3 inside the parentheses. Everybody try that? -3. Tell me when everybody has tried that. Okay. So check it out, everybody. If it's -3, it's on the right side. What if it was +3? Which side do you think it would be at? To the left. What if you do +3 outside? Left and up. What if you put -3 outside? What if you put a minus in front of the whole thing? All right, so let's just focus on the original, the -3, okay? Okay, so go ahead and leave that open, but come on back to the notes, okay? And I'm gonna make a new screen here, and then I'm gonna be done with just this intro today, okay? I was gonna do Khan Academy, but I think I'm going to just finish this off. Okay, so this is a perfect, right? Just a little review. And then if you had +3 graph, you know what? I'm not going to say graph. I'm going to get rid of this. I'm going to say y's go up 3. Just the y's. All of the y's. All the y's. The x's are the same. Okay? And then we said -3. The y's, all of them, go down 3. And then we said x's go to the right 3. Now the graph moves to the right when it's negative, but it's negative. It's kind of backwards. Who wants me to tell you the easy way to remember this or the why? Which one do you want me to tell you? The easy way to remember it or the why it works that way? What would you rather know? The how or the why? The why. Okay. All right. So here's the idea, everybody. It's actually, if you understand the why, it'll help you with all math. Okay. This is just a regular absolute value. So 5 is 5. And go ahead and make another one. So let's put the same input, use the same one. So when the 5 goes in, what happens to that 5? Does it stay 5 or does it get reduced? It gets reduced by 3. So the 5 actually becomes a 2. It actually becomes a 2, and then the output is 2. So the original one, 5 gives like the output 5. But on this one, 5 gives the output is 2. So who got there faster? Who got up faster? The first one or the second? Who went up first? The first or the second? The first. The first went up faster than the second one. Because the second one, if you were like racing, this one is losing 3 every time. So all the inputs, they're losing 3. So if you're losing, you're going to go up slower. And if you look at the graph, these y's, for example, let me pick, I'm going to pick 4, 4, 4. And this one's going to be, and here's an example for everybody, 7, 4. Okay. So who got up to 4 faster? Oh, hold on. Who got, hold on 1 second. All right. Who got up to 4 faster? The red one or the blue one? The red one got up to 4 when the input was 4. The blue one got up to 4 when the input was 7 because the input was being reduced by 3. So it's like a race. Who's winning to go up? The red one's winning to go up because they're not getting reduced. The blue one's getting reduced. For example, the vertex happened here at 0, 0, but this one happened at 3, 0 because the input got reduced. So in reality, it looks like it's going backwards, but it's not. It's just that the blue one is taking 3 times to get up. And the reason is going to the right is because it's getting reduced. The inputs are getting reduced. It's like if we were racing and I held your shirt, I'm pulling you down, right? I'm holding you back, okay? And versus when you do x plus 3, the inputs are getting a head start by 3. So if you put x plus 3 here, then the blue one is actually faster than the red one because they're getting up there faster. For example, when did the blue one become 4? It became 4 at 1. At 1, the input was 4 for the blue one. Okay. All right. That is the why. And we'll talk more and more about that because it's going to be true for all functions. Okay. All right. I know that seemed a little confusing. And this is the intro. I'll talk about it more and more. Okay. The easy way to remember is that stuff inside the absolute value is kind of backwards from what you think. It's really not backwards, but it looks backwards. Minus, the graph goes to the right. If it's a plus, it goes to the left. Okay. All right. Can I get some questions while you guys process that a little bit?
Are we gonna go over this again?
Oh yeah, this is like intro, just real slow. Okay.
Okay, yeah, because I'm like confused.
No, I understand. I apologize. It you have to trust me that it takes a little time for your mind to wrap itself around this. You have to think about it, and it's not like I can just tell you one time. That's not how it is. All right, but we're going to spend time because this applies to quadratics, it applies to IM3, it applies to all future classes. It's the same thing. So the better you wrestle with it. Okay. All right. Here is the Khan Academy. Right. So the original one is X, the original, right? This is the generic one. It says which one is shifted to the left by 6. Which one do you think? And you could also use decimals to do when you get these, but which one gets shifted to the left? This one we know for sure goes down. Like I don't have a way to like draw on this. Here. This part will make it go down 6, and this will make it go left 6. So this is going to go left 6 and down. This is going to go right and down. This is going to go just down, and this one's going to go just left. So I would say D. Would you guys agree with that? And you can also check with decimals, but there's two things happening with these, and this one's going down, and the only one that's going to go left, only left would be this one. Okay, I'm gonna do a couple more. Okay, and then I'll let you guys practice a few. All right, this function can be translated, shifted version of. Okay, so F is the original. That's Freddy. I call him Freddy. He's just the basic one. And this one got. Hey, this is the same one we did. So it got moved to the right 3, which was I think shift said x minus 3. Okay, inside the parentheses, right? So inside the parentheses, the graphs move side to side. Outside the absolute value, it moves up and down. Okay. All right, let me try one more, and then I'll let you guys do some of these. Okay. All right. This one is going to go up 4 and left 2. So up 4, and then inside positive means backwards left. So that would be left. All right, so go ahead and try this first one, and then let me know what you guys think. And I'll wait here. And you can also project the one you have questions on. And yeah, you dropped this on the ground. All right, go ahead and try, guys. I think it's already on your assignments in Khan Academy. And if you have a question, you can actually do present, and it'll show on my screen. All right, which graph is shifted down? Okay, down is not inside. It must be outside. Okay, right here. Remember, on the outside of the absolute value, it's normal. Plus means up, minus means down. Inside, it's side to side, backwards. So for today, even though I assigned 3 of them, I'm only going to require 1 for today. If you want to try the other ones, they're going to be for tomorrow. But for today, I'm only going to do the notes, and there's 1 absolute value. That's it. Okay. And if you got your 4 in a row, try to do another 4 in a row. Okay. See if you really got it. And let me know if you guys have questions. I'm right here. Yes, Claudia. X minus 3 goes to the right, and x plus 3 goes to the left inside. I see your notes here. Yeah, and Evan, I was reading your note on the chat. The easy way is to remember that inside the absolute value is opposite. So if it's a plus, it goes to the left, and if it's a minus, it goes to the other way, right? I always remember one of them, right? Plus left, minus right. Okay, that's the easy way, right? So go ahead and let me know when you have your 4 in a row, and then, or if you have any questions whatsoever. Okay. So Evan, it goes up and down when it's on the outside. See, I don't know if you can see on mine. When it's outside of the absolute value, plus goes up and minus goes down. So if you write yourself a little note on your notes of that, it makes it way faster. Okay. Now, knowing why, it'll take time. Okay? It'll take a little bit of time, and that's okay. Okay? You don't have to understand why today, but if you understand that, it does. Okay. Our Nathan's done. Hayden's got his 4 in a row. Perfect. Okay. So I'm going to post on the Google Classroom for this. And that'll be all today. Today was just a good intro to absolute value.